Hello, concept 3. We have our absolute value stuff. So first of all, we're solving for this inequality. And the first thing that I need to do is I need to get this so it's all by itself. That's the part that is equal to a plus or minus. So we got to move everything else over, strip it away until it's naked. So I'm going to move the 1 over here by subtracting a 1. And then I'm going to divide both sides by a negative 3. So first of all, what I'm going to do is I'm going to just pretend this is equal and get my dividing points, and then I'll go from there. So if I divide both sides by a negative 3, I get x plus 2 is equal to 3. And so now I can say, all right, the stuff inside can equal 3, or the stuff inside can equal negative 3. So x equals 1, or x is equal to negative 1 as my two answers. So it's or equal to. So feeler in. And then I need to figure out which region is actually the solution. So I like 0, 0. I mean, I like a 0. 0 is always easy to plug in. So I'm going to plug in a 0 here and see what happens. When I plug in a 0 here, that becomes 2. 2 times negative 3 is negative 6. Plus 1 is negative 5. So is this bigger than this? I know the 5 doesn't seem like it is, but this is it's a number that's closer to 0. So this is actually technically bigger or more positive than this one is here. So this is actually a true statement. Now we can just check something on the outside just to kind of make sure. So I'm going to plug in 5. It doesn't really matter. So I plug in 5 here. I get 7 times negative 3 is negative 21. And so negative 20 is not greater than negative 5. That's smaller. It's a really small number. And so that is not true. So again, just this section in the middle here. So let's look at the same thing here. This is almost naked, so we've got to just move the 1 over there. So we get that, and then remember, we're just going to just pretend like it's equal for a moment. So either that equals a positive 5 or that equals a negative 5. So 2x equals 8 and x is equal to 4. Or 2x is equal to negative 2 and x is equal to negative 1. So on my number line I have 4 and negative 1. Open circle because it's not or equal to. There's no little sign under there. And now I need to test some points. So plug in 0. So that kind of goes away. So negative 3, but it becomes positive. So 3 minus 1 is greater than 4. 2 is greater than 4. That's not true. So I'm really hoping that like 5 is going to work. So I'm going to plug in 5. That's 10. Minus 3 is 7. Minus 1 is 6. And 6 is greater than 4. Yes, that's true. So I have all of those points and all of those points that are solutions. Okay, let's look at this one here. So here we're asking which of the following has the smallest values. Well, we just need to plug everything in. Let's just check them all in here. So if I plug in 0 into here, I get 2 plus 6 is 8. If I plug 7 into here, I get 5 plus 6 is 11. So that's out. If I plug negative 9, I get negative 11, but then it's a positive. So 11 plus 6 is 17. And if I plug in 3 here, I get 1 plus 6 is 7. So this is the winner of the smallest value. And for this here, largest value, so, we already did that, right? These are the same. So that was that, that was that, that was that, that was that. And the largest value would be that one. All right, 3C, holy cow, that's going to be hard to see. So this one here is at 3, 2. It's important because when we're writing our equation, we need to know the vertex for those 2 points, and we need to know the slope for that one. So first of all, for the slope, I'm over here at 3, and this was here at 1. So this goes over 2, and that's at negative 6, and goes all the way up to 2, so that's 8. So the rise over the run is equal to 4. But it's going down. So everything's negative. And this is my vertex, so remember it's always the opposite with the x, and the k is just what it is. Alright, so let's see here. Looks like we're doing a very similar thing here. This is my vertex. Opposite with the x, it is what the k is. And then it goes through that point. So I have some graph paper I'm going to use here, just so I can see exactly what's happening. So 2, 1, 2, 3, 4, 5, and negative 1, 1, 2, 3, 4. So this was the vertex, right? So it's got to go back there. So I definitely are going down. And let's see, it went, what's my slope? Over 3 and up 1, 2, 3, 4, 5, 6, 7, 8, 9. So my rise over my run is 3. I already said that it was negative, and that was my vertex. Alright, let's look at 3D. So, miniature golf. This is my golf ball. This is the hole. I need to hit it somewhere over here so that it will go into here. So player must attempt to hit a bank shot off the wall at 5, 9. So 5, 9. So this is the spot that we're trying to do. And this is 9, 2, where the hole is. I don't think we meant to say inequality, but let's just look and see. So if this is what I want it to hit, this is what kind of a slope. This is up. This was starting at 1, right? So it's starting at 1 and it goes up to 9, so this goes up 8 and over 2. And here, this is all the way up at 9 here. And I need to write this. This is 9, 2, right? So this is going to go down 7. 1, 2, 3, 4, 5, 6, 7. And over 1, 2, 3, 4. So that is not going to work. What do you mean by inequalities? All right, we're going to go with this and then we're going to back. So this one here is the same exact story, right? And we're trying to figure out if it will go into the hole. So if I hit it perfectly at the 5, 9, going back to here, this slope is not the same as that slope, so it's not going to work because this slope is going to be up 4 over 1, up 4 over 1. And so what's really going to happen is it's going to go up 4 over 1 and then up 4 over 1, which means it's totally just going to like hit the obstacle. It's not going to work at all. So no, it won't, and this is kind of our evidence that we look at where it would hit, and it actually hits our obstacle on there. What we need to do is actually try to make it work, which isn't going to be at 5, 9, because it's not going to happen that way. And so I'm looking at that this is what? We had 7 here, and we had 8 here, and we had 1, 2, 3, 4, 5, 6 here, total that we're looking at. And we need to see what would work. So here, if I went, this one was way too close, so maybe if I hit here, this is 1, 2, 3, 4, and that's 8. So this is up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, and then it goes back the other way, and that misses it. And if I do one more over, this is now 1, 2, 3, 1, 2, 3, 4, and 8. I don't think I'm looking at that right. 1, 2, 3, 4, But this is 7 and 2. And so if I went 2 and 7, that doesn't work either. And this is 7 and 3, as if I went 3 and 8, that doesn't work either. So there's no way that you can hit this perfectly on an exact number to do it.